Good morning, everybody. First presenter here today. I can see that most of you seem to be pretty awake. I think we've got some people potentially streaming this online as well. So I don't know how awake they are, but hopefully this will wake us all up. So I'm going to talk about lighting to IoT and really talking about wireless technology within lighting and connecting the dots to IoT. So this is kind of a very real, practical type of a presentation that I'd like to hopefully step you through. So hopefully you'll learn a little something today. If you don't, you're at least going to get some credit for it. So make sure on your way out you grab the PDH certificates so you've got the credit for this. As I introduced myself before, I'm Mark Lane. I'm the product director for nLight. nLight is one of our Acuity Brands' network lighting control systems. So I think afterwards, if you've got any questions for me, I'm going to be floating around a little bit here at the trade show, seeing what everybody else is doing, but happy to have some discussions with you guys. So today, I'm going to talk a little bit about wireless technology, and I said I wanted to make this kind of real for everybody. So in order to make it real, I think we need to start with some fundamentals. So I'm just going to go over a couple fundamentals about wireless technology, how wireless kind of works, the fundamentals of it. And LEDs are pretty mainstream today for lighting, but wireless is probably not mainstream at this point. I think that there's people certainly using it in certain applications, but a lot of times, I mean, you walk around and you're still seeing the traditional control technology out there. So there's probably some skepticism. That's healthy. I want to talk through some of those concerns and explore that a little bit, get you guys comfortable with the technology. And from there, we can really go a little bit deeper. We can understand what kind of benefits you're going to get from that. And that's really key. If you're going to get a tremendous amount of benefit from a technology like this, you will inevitably have the reason to do it. And once you have the reason to do it, then I'm gonna connect this into IoT solutions and show how that technology is going to enable a lot more. All right, so let's start off a little bit, just a few minutes grounding us in wireless technology. And I like to show some cartoons every once in a while. So our birds here are missing their wires, and actually it's pretty accurate to what wireless is. It's really without wires. So everywhere that you think of controlled or connected with a wire, we're talking about doing it without wires. But how are we doing it? Well, really what wireless means is it's just waves. This is all around us. This is the electromagnetic spectrum. I like to think that when you really want to understand something, you got to be able to explain it to your kids. I've got an 8-year-old daughter. This is from a kid's website here. So if we can all understand this, and we can understand that there's visible light all around us, right? We can see that those are waves. We as people are here in this building. We are giving off energy. That is a wave, and that's actually how most motion sensors work. Most motion sensors use a thermal-based sensor. So you've got a heat signature, right? And as you move, that heat signature moves as well in that space. And that's actually how those motion sensors work. It sees that change, and it does something. So there's waves all around us, and for the purposes of when you think about connected solutions, wireless lighting controls, you're pretty much in this part of the electromagnetic spectrum. So when you hear things like 900 megahertz or 2.4 gigahertz, things like that, this is kind of the part of the electromagnetic spectrum we're talking about. All right, so that frequency band, let's talk about that for a second. We've got low frequencies and we've got high frequencies within that, and they can do different things for us. So on the lower end, this allows you to go long distances. at a similar power level. So you can go a lot farther than maybe a higher frequency. You can also penetrate materials better overall. So if I'm trying to get from here to the outside of these walls, a low frequency is going to work better to do that. It also has lower bandwidth than higher frequencies, and that's really, we'll talk about that in a second, but that's really about how much data can we pass, how much information can we pass. Now, conversely, on the higher frequency, you can pretty much see I'm comparing the two. At a higher frequency, it's going to be shorter distances, or if you want to travel the same distance as a low frequency, you've got to put more power into it. You've got more interference through materials, and we'll talk a little bit about wireless and interference and things like that. And you can, again, carry more data. So a good example of this would be, imagine we're in this building here, and I'm not sure, I'm kind of lost in this large facility here, but let's just say that beyond this wall here was the parking lot or the street, and a car comes up and they've got the music up really loud. What can you hear? When we're in this room, what do you hear really well that's coming through? The bass. I heard that. Yeah. So that's a low frequency, right? That travels longer distances, easily penetrates through maybe construction walls, versus that higher sound, the higher frequency, the highs. As you walk outside, you get closer to that car, that's when you start hearing those, right? So pretty clear example of that. Let's talk a little bit about the common network topologies of different networks. So Wi-Fi, Bluetooth, cellular, Ethernet. You also have proprietary systems. You'll hear people say, I've got a mesh system as an example. These are all common network topologies. They all follow this first line down as a standard that they're meeting. They also have differences in how much bandwidth, how far they can go, potentially how much cost it is. So they all have different characteristics depending on what you're trying to do that give you what you're looking for. There is one here that is an imposter in my presentation today, and that is Ethernet. This is not a wireless technology, but all the rest are. All right, so let's get a little bit more into detail about these networks. First, point-to-point network. This is where a device talks to a device. You're not really going to have any messages that get routed further beyond that in this just very basic point-to-point connection. You're not going to push information further on or backhaul information. And you're really limited to two devices. Really common application of this is Bluetooth. So a lot of people, obviously you've got maybe Bluetooth earphones that connect to your phone or your computer. You've got maybe a watch that connects to your phone via Bluetooth, that single connection. That's a common example of that. Next one, star networks. So this is where a device talks to a central device, and the messages are routed to other devices in the group. This is capable of backhaul. If you've got that center device, being able to go connect to another deeper network, you can backhaul information, or you can share information between devices. And a common example of this is Wi-Fi. So I think everybody's pretty familiar with Wi-Fi today as well, right? Anytime we're indoors, we're typically using that a lot of times to be able to connect, and your device is going to connect to that Wi-Fi access point. That access point is your central device in the star network. The last one, a mesh. This is where devices talk to all devices within range. So in the star, we're going only to that central device. In a mesh network, we can have devices that connect to other devices and carry that along. So messages are routed through connected devices, typically the shortest path. This is backhaul capable and extended networking as well. Zigbee, Z-Wave, even Bluetooth mesh, if you've heard that as well. Those are all common brands or protocols for mesh networks. And lastly, I also want to point out they all have kind of a latency. So this is how fast that information can travel. When you've got just a very basic point-to-point network, you've got one connection, you can have information flow very fast. And on the converse side in a mesh, you have to go from device to device to device to carry that information around. So that has an inevitable latency built into it, so it could be slower from a speed perspective. All right, let's kind of finish here. We're talking about bandwidth and range. So bandwidth is the maximum rate of data transfer across a given path. And depending on your application, this can vary greatly. So I'm in the lighting control world. We are passing very, very basic messages, very, very low bandwidth needs in that type of a application. If I'm at home and I want to stream the game from my living room on my phone, that is high amounts of data. That is a lot of bandwidth that I'm passing. And in fact, in that example before, I talked about the frequencies. If you are in your living room and your access point for your router, your Wi-Fi router, is in that room, you're probably using 5 gigahertz as your frequency. That's pretty common today on phones to have that. It's a higher frequency, you can pass more data. However, the range isn't as good. So if you go to the opposite corner of your house, upstairs, and you're very far away from that router, your signal might get a little weaker, the picture might not be as clear. You're probably using 2.4 gigahertz, which is also on your phones. So you've stepped down to a different frequency. You're not able to carry as much data, so that picture is not as clear, but you're able to actually carry it. You're able to actually get the information because it can go a longer distance. So distance, perfect segue there to range, distance required for communication between devices. Range depends on really, again, that application that you're trying to do. Again, in the lighting control world, if I've got a city that I have 40,000 lights to manage as a utility, a mesh system works extremely well because I've got many, many devices over a long range that I've got to connect, and that is the perfect scenario for that. In fact, you really don't have anything from a latency perspective that you're concerned with. Maybe you're having the lights, come on at dusk. Maybe you have a period of time in the middle of the night where you might bring some of the lights to a lower dim level to save some energy on a schedule. All that information can flow out. It can take some period of time. When I say period of time, I'm talking about maybe 5, 10, 20 seconds, and that's totally sufficient for that application. If you're in a parking lot, though, it's very different, right? If somebody has brought the lights down lower at a point in the nighttime to save energy in a parking lot, but you drive in with your car and there's motion sensors, you want those lights to respond immediately so you can see where you're going. And you're going to need a much faster response. You're going to need maybe more of a star network to have that experience. And if you've ever seen this, you may have seen a mesh network, a bigger mesh network in a parking lot like that that's mesh. You'll typically see what's called popcorning of the lights. So they'll kind of come on in stages over a couple seconds. So depending on the application type, different networks are appropriate for what you're doing. Okay, so a little bit of fundamentals. Let's go through some of the concerns, because certainly appreciate that people can be skeptical about wireless, and we want to talk about this. So you guys can see a theme here. I'm starting out all my presentations, my different content. We don't want anybody here to become a victim, like this gentleman here. But I will say that there is good explanation and good reasons to make wireless work, and it is not going to be as challenging as you think. You will not, I promise, become a victim. Okay, so first concern, wireless is not reliable. You guys see this beautiful little picture here I have of a bunch of, looks like network switches maybe, connected all together. And you know, you got to start with the technology that's out there today. You got to start with wired connections. And is that reliable? This requires physical connections. It requires, there's a certain quality of the cable that is part of that reliability. There is a quality of the installation of the cable, whoever's installing it. There is a quality of the actual cable connections. So you've got a long run of cable, but you've got to terminate those as well. You've got, obviously here, confusion of multiple connections, not really maybe being able to make sense of what's going on. And you've got time. No matter what, no matter even how it's installed, over time, it is a material. It will eventually break down and become unreliable. So I think number one, we can think about wireless from the perspective of its comparison to wired, and that we've improved to eliminate all these points of failure with wireless technology. But I'm guessing that you probably don't think about this, the comparison, when I say wireless is not reliable or that concern. So you're probably thinking about that range and maybe getting to those devices, getting around obstructions, going through materials. How do I know? How do I know that this is going to work? So, number one, I want to also point out wired systems have a finite cable length. So it can't go forever. Whenever you have wired connections, is going to have a length that it can go. I don't know if anybody's familiar with the length of a USB cable, but it only can go about 15 or 16 feet before you have to put some power to it, try to do some other things with it to extend that length. So a wired system has a finite length, so we need to think of wireless systems in the same way. And the nice thing about wireless systems is they don't need to be one giant group, one giant system all connected together. We can simply logically lay things out the way that the application presents itself. So if I want to do wireless controls in this room, I can have all the devices wirelessly connected inside this room. And I don't need to go outside of the walls. I can have a little network of the hallway out here. I can have another network in a different room. So that manner of which you're laying it out is important and can very easily make wireless very simple to understand and work. Wireless groups can be networked together with other wired or wireless connections. So even though you may do some very local stuff, you can also bridge that and go further and connect devices together. You can use, like mesh technology or other forms of networking to connect devices to devices and carry and backhaul. You can also use wired as well. You can have wireless in a room, and then maybe from here you're going to have a wired connection. That's literally how Wi-Fi works, right? There's typically an access point, and that's wired, but the wireless that we're all enjoying from our laptops is in that local area. Ultimately, what I'm talking about here is really it's about management of the product. In the previous picture that I showed, you've got wireless, or you got a wired rat's nest. And here in this picture, you've got very clean run cables. And I certainly wouldn't appreciate anybody doing the previous. I think everybody's going to be doing these nice tight runs and kind of zip tying everything together when you're doing a construction like that. No different with wireless, right? We logically set up the ones that we want to be connected together. and that management of the product is really key to success. So know the system, know your limitations, and apply as appropriate. Okay. Concern 2, wireless systems are not secure. So 2020 to 2021, 105% increase in ransomware cyber attacks. We're all living this, right? We see it all the time. Security is a big concern. And ultimately, there's really 2 points here that I want you to take home. Number one, it is important who you're working with, because there's a lot that can go into this. And if you're not partnering with a company that understands this and has multi-level security models built into their development, built into the governance of the product, built into how they're preventing, looking into being visible of active threats, things like that, it could be a problem. And if anybody says that their system is not hackable, run far away from that person. Everything is hackable, right? But there are some tools that you can use to make sure that you are trying to avoid any of this going on. So air gap networks, this is as a term that I like to use to define having a network that is not connected really to anything else. So I talked about this room. I talked about doing lighting controls in this room. I can do wireless lighting controls in this room, and it connects to nothing else. So it doesn't connect to the internet. It's not, somebody can't get on their computer from anywhere in the world and try to hack that network. They would have to be here in range of this room to be able to do anything with it, right? And I get on the phone many times with a lot of IT staff who have a lot of concerns about this. And that is a very easy remedy to say, keep your networks separate, right? Air gap your network so that you limit that potential for the threat. So again, partner with businesses that have these security models in place and the know-how to support it, and apply wireless systems as appropriate for your business. Okay, concern 3, wireless technology changes too quickly. So I call this FOBO, fear of better options. I think this is something that we all struggle with sometimes on a daily basis, no matter what it is. We're afraid maybe I might want to wait a little bit. There's something better on the horizon. My push mower just broke down this week, and I took it into the mechanic, and they said, you need a new carburetor. It's going to be $220. I got a just gas push mower. I'm not going to spend $220 to fix a carburetor on that. So I'm looking and thinking, hey, maybe I can move into electric and I don't have to worry about all those parts anymore, because there's a lot of electric mowers out today. But I don't know if they're good enough yet, right? Do I want to make that investment? Am I sure? Well, let's use a very relatable opportunity, and that's LED conversion. So I hope that many of you are pretty familiar with LEDs now, and they've been around quite a while. And let's consider that scenario. Let's consider back in the day, almost 10 years ago, in 2013, you could replace a 400 watt metal halide outdoors with an LED at 143 watts. So my grandpa friend here said, you know what? I think I'm going to wait a little bit. There's probably going to be a reduction in that energy consumption. They're going to get better at it. I'm going to wait. So he waited. He waited 5 years to do that upgrade. 2018, it was at 102 watts. So it went from 143 to 102. Absolutely. Like, there is a tangible benefit in energy consumption there. So he implemented then, saved $785 per fixture over 10 years. And I say over 10 years because when you're putting these LEDs up, that's if you're using a quality product, that's kind of the expectation that they're going to last anywhere from 10 to 20 years. Our other friends over here at 2013 said, let's do this, right? 143 watts, $75 per year. They saved $1,350 per fixture over 10 years. This is that opportunity cost of, even though the technology improved, you lost out on 5 years of energy savings, right? And that is a substantial amount when you go from 785 to 1,350. So number one, I think with wireless technology, you need to understand that this is absolutely very real, and I'll show you some slides later on that. But you don't want to miss out on the opportunity cost today and as we move into the future. The other thing that typically holds people back is not being concerned that the technology is too new and more things are going to come along in the future. Well, pretty much everybody now is familiar with Tesla, right? I think everybody knows that car company and what they're doing. And one of the very interesting things about Tesla, and this is really common nowadays for any technology product, including wireless lighting controls, you've got the ability to get enhancements and upgrades via a firmware or software update. So Tesla does this on a regular basis. They will send out, sometimes they're free, sometimes they're paid for, but you can get upgrades to your car. And I've watched that car. I don't have one personally, but I have friends who do. And I've watched that car go from what it was in the beginning when they bought it to they're at the restaurant and they push a button on their phone and the car drives and comes and picks them up. So that driverless technology didn't exist 3 or 4 years ago when they first bought the car, but they're still using the same car and they've got that capability. So this is one of the beautiful things about it now, is that the hardware is really not going to change much. You're really getting the changes in the way of firmware and software updates. And obviously you've got a potential with wireless to be able to upgrade that very, very easily. And then the other thing I want to point out is that many systems are designed to scale over time. And when I say over time, I mean for the customer whenever they're ready to expand. So the basic level of lighting control functionality that you could get in a room where you turn a switch on, or you've got maybe a sensor turning lights off if nobody's here, those basic control capabilities are fundamentally their table stakes in a wireless system, and you can go literally that far. You don't need to go any deeper than that. You can basically get the same capability, but you know that in the future, when they're ready to go up and ready to scale and ready to increase that capability, you have the hardware there that can do this, right? So that's another really strong thing here. And ultimately what this means, and this is one of the key points, if there's anything to take away from our presentation today, is to anchor your decision in the return on your investment. You absolutely can make a very sound investment right now, and it will prove out very quickly, and it will continue to be able to allow you to grow and scale with your business. So that's going to carry me into the final piece of my presentation, and really this is the good stuff, right? This is where we're going to understand getting from wireless to IoT. And I want to talk a little bit about the rewards of wireless to kind of lead us in there. But first, let's see what is IoT? What is that term? It's kind of become an ad nauseum thing now. I don't know if anybody else feels that way. I'm constantly hearing people talk about IoT for the past 5 years. And again, healthy skepticism is good. I love this cartoon because the dog on the right here, like they drew that right into him. They got that confused look, like this other dog is crazy, I think. And that's a lot of times where first adopters of new technology are, but Internet of Things is not new. Internet of Things describes physical objects or groups of such objects that connect and exchange data with other devices and systems over a network. So here I'm just showing, lighting controls. That's the product line that I have been using and providing for many years. And we've got some lights, we've got some load controllers, your power pack type devices to control those lights. You've got sensors, you've got wall switches. Nothing really revolutionary going on here. This is what's called networked lighting controls. We're connecting those sensors and switches and luminaires together for control. And then we can also connect those devices to a broader network. So here on the right, I've got what's called a gateway or maybe an access point. So those devices are taking those, that collection of devices in a room and pulling it back to a deeper system to do more with that. This wireless network lighting controls, this is an IoT solution. And I know that, again, this is not predominant like LED is, but there are a lot of people implementing these products and using these. And by the definition, this is an Internet of Things. This is an IoT solution. So we're all living and doing this today. But I think that there's even more that you guys are probably looking for in this presentation when I talk about IoT and kind of what you imagine in your head. So we'll get there. We're going to finish off with wireless lighting controls and why you should implement them. So I told you before in the previous slide, I wanted to talk about return on investment and why I think it's there for the taking. So first things first, always with network lighting controls, benefit you get is energy savings. This is a report that the Design Lights Consortium did. They're an independent third party for lighting efficiency. They did this large study across many different application types, found that on average, you're going to save 49% in energy going from traditional controls to networked lighting controls. That increases to 63% on average if you have what's called LLLC. This is luminaire level lighting control. Luminaire level lighting control is just every individual luminaire can be controlled. And typically they're also including a sensor in each control device there. But you can see that there's a tremendous amount of savings. And I want to think back to that opportunity cost and anchoring in an ROI. You've got a tremendous amount of energy that you can save. You're putting up LEDs at the same time typically when you go in to do a job. So those LEDs are, again, for reputable company, probably going to last anywhere from 10 to 20 years. That's 10 to 20 years of savings of 49% or possibly even 63% savings or even more, right? Depending on your application type, warehouse 68%. There is a tremendous value in energy savings alone. The investment is there on just that. But there's more than that. So luminaire level lighting control, you're going to get a substantial amount of savings by doing this. So we're going to put the controls into a fixture. What does that do for us? Number one, cost and reliability savings. We live in an AC world. All our outlets, all of our electricity, whatnot, it's typically run on AC. When you've got a control device, it's, a lot of things today are actually running on DC. And you've got to do that conversion. You've got to convert from AC to DC. In fact, that's actually already going on in a luminaire. Luminaire has a driver. It's basically a driver, a light engine, lights, the LEDs, and some sheet metal, plastic around it, right? That driver, it's purpose really is to convert AC to DC because the LEDs operate off of DC. So you already have a device in the luminaire doing this AC to DC conversion. If I have to put a load controller in a space to control lights, I've got to take an AC voltage, convert it to DC, and use that to control my lights. I don't have to do that here. I can eliminate that conversion in the control device because it's already in the luminaire. So I could just get DC voltage right off of the driver and power my control device. So I eliminate that. I also eliminate protections like surge and EMI. Again, our AC infrastructure here is not the cleanest in the world. There can be a lot of surge, a lot of EMI. You've got to have protections built into your product to do that. Same thing, again, the driver in that luminaire has to also have these protections. So it's already doing it. So you don't need that if you're getting your DC voltage off the driver, it's already doing it. The last one is a relay. So this is a mechanical component in a control device and that's going to control luminaire. And that relay is going to open and close, lights on, lights off. That is the highest failure rate component in a control device. If you can eliminate that, you're going to increase your reliability substantially. And guess what? You can. So since we have a connection directly to the driver, we can tell that driver to turn on and off. Just send it a basic signal on, off through the control device. So you've got the ability to remove the highest failure rate component. So lots and lots of opportunity for eliminating cost and reliability out of the control device by going this route. Interoperability savings, compatibility guarantees with one product purchase from a single manufacturer. Now, we've got standards out there. We've got, control systems and lighting. You can integrate them together. It all works most of the time. But there is probably at least one time where you've been on a job site or worked on a project where there was a problem and they didn't work. And manufacturers maybe were pointing fingers at one or another, right? That can be eliminated because now you've got one hand to shake. A lot of people say a throat to choke, but I like to say one hand to shake. With one company that you're going to, one single product, and that product has been tested to work as a single product. So the control and the lighting together is already tested. So you're getting a guarantee that that's been done. And you're also getting the understanding that I know that these two things have already been tested together. Design simplification. If anybody does any designs, especially in lighting or lighting controls, you've got to do layouts, right? You've got to look at a space and, okay, how much light do I need? What kind of lights do I want to put and where do I want to put them? In lighting controls, you have to do the same thing with motion sensors. If you have to put a motion sensor in a space, okay, I got to figure out how to do the layout so that I've got coverage for this whole room. Where do I put the motion sensors? How many do I put where? When you have a sensor in every fixture, you're covering the whole space because the lighting is covering the space. So you're going to have sensor coverage as well. So you've eliminated that whole step in the design process. So your design gets a lot simpler. And then lastly, you go to actually install the product. Well, number one, I'm going from a luminaire and a load controller and a sensor, 3 products into one. So number one, I've got fewer devices to literally install. But with wireless, I also eliminate the low voltage wiring. Again, very beginning of my presentation, those birds on the wire, we're eliminating that in wireless. We're just getting rid of that wire that is there. So you eliminate all of that labor and material of the wire itself in the form of wireless communication. And this gets incredibly easy where, especially with LED, when you do a retrofit where you're taking out the previous luminaire, you're putting in a new one, you wire power up, and guess what? That sensor's already working. It's already pre-programmed to dim the lights down when there's no motion present without you even doing any commissioning or work with that system. So that kind of leads me into the next benefit, which is application diversity. A lot of products today, we're talking about indoor applications. That's probably what most people are familiar with lighting controls, switches on the walls, sensors in the ceiling, that sort of thing. And obviously you can use wireless in a new construction application. You're just getting rid of those wires. You can also use it in retrofits where wired is a lot more difficult to do. So you've got a lot more reach in that building, whether it's new construction or retrofit, to do this. What about the parking lot, right? Typically today you've got maybe a different system outdoors than you got indoors. What if you had a parking garage near that, right? Maybe even another system. What if it's an industrial application? Is it a different product as the indoor product, as the outdoor product? Well, one of the benefits of wireless is they work extremely well in all these applications. There's all these costs and benefits apply, and it can be one system. So you don't need to learn all multiple types of systems to deploy this technology. You can just learn one and apply it to all the different application types. And last thing is improved occupant experience. So lots of benefits from a cost perspective, energy savings, installation. But at the end of the day, we're all the ones that got to suffer with this stuff, right? We're all the ones that use it. And could it be better? Could we have an improved occupant experience with network lighting controls? Personalized control of individual luminaires. I talked about how we can put the control technology in each luminaire, and we can get control of each of those individual luminaires for doing some specific things. So I don't know if anybody notices here in this room, we've got a lot of downlights, but there's a row of downlights right here, right above me, that are off, right? It's a presentation scene, right? That's what we're in right now. We're in a presentation scene. So there's a controller on the back of the wall there, and I guarantee you that this is the presentation scene. So hit a button, changes the lights, brings these off and those at a certain level. Imagine in a classroom, this switch here, it's showing, hey, I've got general lighting, I've got maybe readings, so maybe I'm going to dim down the lights a little bit and make it a more comfortable experience for the kids to read in. Testing, maybe I'm going to bring that light level up a lot higher, making sure that they're focused when the testing time comes. And then energy savings, I'm going to drop it down significantly, and I'm going to let my motion sensors work for me. So you've got the ability here with a network lighting control system to provide this experience of personalized control. Group response to motion or daylighting. So this is a great example in an outdoor space. You've got a parking lot, it's late at night, you're walking out of the building, and if you've got motion sensors on every fixture, what happens in that scenario? So we walk out, we walk under that first fixture, the motion sensor sees us, that first fixture, it's dimmed down to save energy at that time. It comes up to full brightness because we're there. Unfortunately, the rest of the lot hasn't seen you yet, so the rest of the lot is dimmed down. When that light comes down, your eyes need to adjust to that new light level, and they adjust, and now it's harder to see because everything else out in front of you is dimmed down. So we're saving energy, but what's that like for us? And in fact, why are those lights even there in the first place? They're there for us, so we can see where we're going, right? There's no other point of those lights being there. Without having group response to motion, where when you walk under that first light, the motion sensor sees you, and you can turn all the lights in the parking lot together up at the same time, you're not going to get the experience. You might as well go back to just sunrise, sunset, on, off, because that's what we need. That's why they're there. They're there for us so we can see. So really, to get that benefit of energy savings and the appropriate user experience, we need to have group response to motion. We need to have a ability to network those devices together. And then the last one, ability to reconfigure spaces for occupant or space changes. So we're kind of coming out of COVID a little bit right now, right? Thankfully, we can all be here without masks on and all of that. But I imagine the work environment's changed. I'm working from home. 2 years ago, that was not the case. And as we start to go back into the offices, what's that going to look like? Is the space going to need to change? Is a business need change over time? Does, lighting controls, is that something that we may need to adjust depending on who's there, or depending on, the business operation and how it may need to change over time? Again, you're putting up LEDs, you're putting up a potentially control system. You need to be able to reconfigure. You need to be able to change it dynamically when the opportunity presents itself. And this is something that you really can easily get and really only easily get with a wireless lighting control system, where you can literally pull out your phone, pull up an app, and make changes to that space like that. I always bring that up as well about, when you're finishing a job and you're turning it over to the customer and you've got it all programmed the way that it was supposed to be on paper, and the customer looks at it and goes, "That's not what I want." Right? Does that ever happen? Nah. Yeah, so what if you could be there with the customer and, "Oh, that's not what you want? Okay. How about this?" "Yep, that's what I want." I mean, that's what's possible with wireless technology. All right, so I'm going to wrap up here, bring us into the IoT piece of it, which I'm sure a lot of people want to know, but I think it's important, again, that we build this bridge, and you've got those fundamentals. We remove the skepticism. We understand all the benefits that you can get out of a network lighting control system and wireless technology specifically. So we can go a lot deeper than this. Control beyond lighting, we'll talk through an example of that, but we've got the capability, as you're connecting devices together, to do things that are different, that are not just for that sole purpose of why you bought the product for lighting control in the first place. Actionable insights. I've heard this spoken a few times now. Buildings are a living thing. They adapt and change over time, and it's important, especially people who are managing buildings, to understand how the needs are changing, how their building is operating, getting insights so that they can effectively manage their building. There's a lot of interesting things from an insight perspective that you can do, and new experience as well. So I'll give an example of that. There's lots of things that are just unrelated at all to what we're traditionally expecting we're able to do inside of a building. And so I'll talk about an example of a completely new experience that you literally will use the technology and lighting controls to do. So this first example is building integration. So using sensor data can be used to influence HVAC controls, adding to energy savings. So in this example, there was a pharmaceutical company in Northern Illinois, and they had laboratories, and in those laboratories, there's some toxic fumes as part of their process, and they need to obviously remove those. So they've got fume hoods that are requiring there to be continuous outdoor air to keep these laboratories safe. So we're in the northern hemisphere here, northern part of the country. You guys know what it's like in the dead of winter. So does somebody in northern Illinois, and what that could do, bringing outdoor air in, and the energy costs associated with that, right? Especially as you're trying to keep a building warm. So in this example, they did an LED upgrade. LED fixtures were equipped, all of them, with occupancy sensors. communicating wirelessly to building automation controllers. So we connect the devices to a gateway. That gateway can connect into the building management system. So it can connect into the HVAC controls. And there's a standard called BACnet in the HVAC world that, the lighting companies are all should be. Most of them should be supporting using that standard. And so you can just easily pass that information across. And since we've got occupancy sensors in the space, we know when people are there. And we're using it for lighting controls, but we can share that data to the HVAC system. And in this case, whenever someone's not there, they can decrease that airflow required because there's not somebody in there, they're not doing the process, and they can change that HVAC relationship and get a significant amount of energy savings from HVAC. So they got savings in 4 different ways. They went from T8 lamps to LED. They got energy savings from that. They have the lights are off when the room's not occupied, lighting controls. They've got savings from that. They're trimming and using daylighting controls. So they're some of the fixtures they may order them at a certain wattage, and maybe it was a little overkill. They can actually trim them down slightly so that they're really hitting the right output for the task. Save a little bit of energy there. Use daylighting controls. They've got windows in that's office. When there's daylight in, they don't need the lights on, so they're getting savings that way. And then this airflow reduction, which was actually pretty substantial, they've been able to really decrease energy consumption tremendously. Second example, space utilization. So if some of you may be familiar with this, if you're not, what this basically means is, again, talking about those occupancy sensors. We know because we're using them for lighting controls and turning lights off when they're not needed, but we know when people are in a space. And if we can collect that data and look at it over time, we can potentially gain some insights into what's happening in that application. So in this example, there's a healthcare business in Boston, Massachusetts. They had about 67,000 employees across 2 buildings in Boston. And they had a kind of a real estate expansion. They said, we're probably going to expand, or I'm not sure in this case, this may have been a consolidation of 2 companies, bringing them together. But they've got 2 buildings. They're not fully utilized. And when they took a look at it, they said, we think there's an opportunity to reduce this down to 1 building, but we don't really know. We're just kind of thinking that there is. So they needed to get the data to make the case. So they installed some sensors. I think in this application, they installed them separate lighting controls, but again, you can use that same sensor technology in the space, pull that data back, see how a space is being utilized every day over time, whether people are there or not, or how often they're using that space. And they found the utilization was only 20% when you look at those 2 buildings. So they had the data to prove their point, and they terminated the lease, moved employees, saved more than $6 million annually. And again, substantial amount of savings doing something completely unrelated to what the product was purchased for in the first place, which is lighting controls. My last example is probably my favorite. So indoor positioning, BLE and lights allow for wayfinding. Some of you may know what this is, some of you may not, but everybody's pretty familiar nowadays with being outside, getting directions, having a blue dot on your Google Maps or your mapping application, right? That's positioning. We don't really get that same experience indoors because we don't have the ability to really see and triangulate with the GPS satellites that are up in space. That's really mostly how that's done. But if we incorporate in wireless technology indoors, we actually can do that. And our major retailer in the US, Target, they did something like this. So they deployed LED across all their stores. The reason why I love this one is they did this. You can pull this article up. It was all about energy consumption. It was all about reducing that demand. So they implemented lighting and technology in the lights, and they reduced their output by 10% annually, power across all the stores. So all the power they reduced by 10%. And that was their ROI. That was why they framed it up, and why they did this was that bogey. But at the same time, they put in the technology using Bluetooth, and they also use a thing called visual light communication. But you can use Bluetooth to do this, where you're using that Bluetooth sensor and a dense network of sensors all across in every light to triangulate your position, because everybody's phone has a Bluetooth sensor in it as well. So if you guys have never done this, literally, next time you're at Target, pull up the Target app, and they have a little floor plan. And when you hit that floor plan, you'll see a blue dot drop right where you are. And as you walk through that store, that blue dot's moving with you real time. That's in the lights. So indoor positioning, wayfinding, finding your way. This week, I heard a presentation about, retail might not apply to a lot of what you guys do, but I imagine warehouse might, right? Warehouse applications might. I heard about one where they did asset tracking. So they put a Bluetooth sensor on every forklift in the warehouse, and they looked at the data over time. They saw how many were being utilized, how many weren't, where they were going, all that stuff. And obviously they looked at that data and said, well, we can get a ton of savings, because a lot of these forklifts are not being used. So they could terminate leases on some of the forklifts and optimize their workflow. But one of the things that they didn't realize that killed their efficiency, and they didn't know it until they had the data, was they weren't charging the units between shifts. So, and at lunchtime. So those forklifts, you've got to plug them in and charge them. They would just abandon them at lunch, come back. At the end of the shift, they wouldn't put them in the right spot, put them to charge. Guess what happens? The second shift comes in, and their forklifts die, right? And that's probably why they needed more forklifts. So they didn't expose that until they saw the data, and they were like, oh, they're not plugging them in. They're not taking them back and following the process. So using this, technology, Bluetooth and lights, and using that, it's either built in or it's part of the lighting control system, but you got an opportunity to do some very unique things that you wouldn't otherwise. So final thoughts, wrap us up. I know we're out of time. Wireless is just waves, whether it's AM radios, microwaves, people, or light. Wireless networking improves on the limits of physical connections, applications, and installation costs. I think that this is a technology that we're just replacing the old, and we're improving on it tremendously. Wireless lighting controls provide strong ROI without sacrifice. Again, one of the things that I want you guys to walk away from is that there is a absolute, very quick, easy return on your investment, and you don't need to sacrifice, because you're going to have a lot of benefits now and in the future. Those benefits aren't just for the designer, the installer, the building owner, the user. They're for everybody. And obviously, we've connected the dots. Lighting controls connect to future IoT solutions or are presently available today. I said I wanted this to be a real life presentation. Everything that you saw here today is real. It's happening. IoT solutions are everywhere, whether you think it's new or not. We're doing it all today, and I thank you for your time.